Let us now see few examples on the concept list. Now, the first example is it just to create a list and to just fetch the values of the list. So here I've created a list by name new, and I've used the square bracket here which represents that this is a list, and I have three values here. All the three values are of the same type, that is a string, and I've just tried to print the values here by giving print of new. So if you observe here, it is doing nothing much here, it is just printing the values in the list. So this was a condition or a case wherein all the values in the list are of the same type. Next, let us see an example where we'll have a list which has not just the same type of values but also the different types. So here if you see, even that is also acceptable. All the values are just printed here when I try to print it by using the print here. So I've initialized a list here by name new, and I've used an integer and also floating point value. Even that is also acceptable. Now let us see a third example. So what this third example does is, so here, with the same list, what I'm trying to do is I'm trying to print a particular value by using indexing. So just like in strings, how we use the indexing concept, even in lists it is possible. So if you want to access a particular element, if you know the index of that element, you can directly access it by using the index. So here I am trying to access the index 4 here. So 4 means 0, 1, 2, 3, 4. It should be printing 123.46. So let us run this. So it is printing 123.46. So in the same way, any particular index you want to, you can try to fetch that value here. So if I am using new of 3, it gives me 123. And in case I'm trying to fetch or use an index which I have not initialized any value, then it is index out of range. So I'm trying to access 7 here, so I'm not initialized any value for this index, so it gives me an error stating list index out of range. And the next concept is, unlike our strings, lists can be changed. That is, reassigning of the values can be done, which means that lists are mutable. Unlike strings, which are unmutable, lists are a mutable concept or a mutable set of values, means you can reassign the already assigned values in the list. So we'll see another example which is doing this reassigning here. I've taken another list here, new, and there are 1, 2, 3, 4, 5 values here. So initially the new value, initially the index 4 value was 56. Say I try to print here. So before reassigning, if I try to print new of 4, we'll see what it is, and after reassigning, I've reassigned it to 33 now. So initially it was 56. After I have reassigned it to 33, and then I have tried to print that new of 4. So what does this concept tell is, any values within your list you can reassign it. It is not like our string concept. So any changes in the value can be done easily. This example is to tell that lists are mutable. Let us see another example. So this example, again I have initialized a list here by the name new, and I am trying to search if a particular value is present. Say I want to search whether 34 is present in my list called as new. Then I use the Boolean operator in. I use 34 in new. So if 34 is present, it gives us a true, else it gives us a false. So I have initialized that 34 is in new to A and I'm trying to print A. So if 34 is present, it will give me a true. In case I'm trying to search 35, which is actually not present in the list, so it should give me a false. So to traverse or to find or to search a particular value within your list, you can use your in operator, which will directly give us a true or a false based on whether that value is present in the list or not. So here new is nothing but the name of our list which we have initialized here.